about Authorino and externalizing Auth. I will speak to you as if you were all software developers, okay? So imagine you have an application. Let's say it's a Golang application. In fact, imagine you have multiple applications. Let's say another Java application and an application written in Ruby. We're talking multiple applications, multiple implementations, possibly multiple Auth implementations. For example, imagine your Golang application contains a few pieces of code to connect to two legacy systems that the application needs to integrate with. Perhaps the Java app went for a different approach, like importing a code library that handles the communication with the company's central authorization server. So, multiple technologies, multiple standards, multiple ways to implement the auth logic. And with the auth logic baked inside the application's code, that easily lead to coupling between the auth part and the rest of your application logic. Besides, things might be too close to each other, so there might be a larger area of impact in case you need to make changes. Also longer CI/CD pipelines, etc. Even when it's well implemented, following all the best practices, at the level of the organization, the overall set of auth policies and rules is still scattered across multiple code bases. Often, that translates to duplication of code, rules that are difficult to inspect and to audit, without mentioning the dependency that the auth has on the rest of the application in terms of scaling. If you need more power for auth, you need to rescale the entire application up. That is something that might sound like a good thing at first, but depending on where your bottleneck is, you might not want that. Now imagine that all the auth logic is pulled out from the code into a separate layer, one that we can delimit the perimeter and say, this is only auth related stuff that goes here. Right away, we'd be gaining some separation of concerns and decoupling, which translates to improved maintainability and things like finer grained testability. It's also now easier to inspect the auth policies at the level of the organization, as you can see. But it also means that you can simplify your application's code base and focus only on the core business logics of each application. Provided that now those two layers are decoupled from each other, and now you also have more flexibility to change things around. For example, let's imagine that we want to replace these legacy systems of the Golang application with some novel auth technology that we want to experiment with. Also, things that we spot being done in different ways before can be standardized and begin to adopt more organization level policies. Moreover, things that are identically done can possibly be merged into one, and finally break with that one-to-one mapping between scaling the auth layer and scaling the application layer towards more of a end-to-end model for scaling here, and effectively allocating resources better and more economically. Well, helping app developers to externalize auth layers and start leveraging decoupling, separation of concerns, simpler application code bases, standardization for auth, yet with the flexibility to comply with company level policies at the same time that supports the legacy and paves the way to the future, is the purpose of Authorino. So what is Authorino then? Authorino is an external authorization server that allows us to model external authorization rules to verify authentication and access tokens, and enforce authorization policies at request time in a totally tailor-made way fully configurable and manageable using Kubernetes custom resources. Authorino adds yet fetching of metadata from external sources, tools to apply token normalization when trusting multiple sources of identity, injection of auth-related data in the request, like usernames for instance, and highly configurable and dynamic caching. And how does it work? For a reverse proxy / gateway external authorization kind of integration, it looks like this. In the control plane, an app developer built an API that we will call here the upstream API or upstream service, and deploys that API behind an envoy proxy, meaning that envoy will be the facade to access the API. Then the developer writes an Authorino AuthConfig Kubernetes custom resource, which states the recipe of auth rules and policies to enforce for each authorization request. Like, for example, validate tokens issued by identity provider X, enforce authorization rule Y, and etc. Moving now to the data plane, one interested in consuming the API obtains an access token from an authentication server or trusted issuer and sends the request to the API carrying that access token. It is Envoy that will receive the request. Before forwarding the request to the upstream service, Envoy sends an internal gRPC request to Authorino. Authorino finds the pre-cached AuthConfig recipe to enforce and triggers it for the context supplied by Envoy, effectively verifying the request, occasionally fetching metadata from external sources, enforcing all the authorization policies and rules, and then builds a response to Envoy with either OK or not OK, meaning access to the upstream shall be granted or denied. If access is granted, Envoy forwards the request to the upstream service, which effectively serves the request. The reverse proxy or gateway external authorization approach, where Envoy receives the request, talks to Authorino, and Envoy redirects to the upstream, is the main way to use Authorino. But there are other ways to use Authorino, such as without the proxy in the middle, with the upstream API talking directly to Authorino. And a sub-use case of that is of the Kubernetes API talking to Authorino to validate requests sent to the Kubernetes API server. The rules to validate the payloads sent to the cluster's API are expressed in an Authorino AuthConfig custom resource. And just to complete the list here, yet another way to use Authorino would be with no protected upstream service at all, but with just a client talking to Authorino directly or through Envoy to ask questions such as, can I send a GET request to api.io/foo, for example? Multiple topologies are possible here. The first one being the one where a centralized gateway that routes the traffic to multiple upstream services uses Authorino to check authorization first. Another topology involves using Authorino as a centralized policy decision point, but keeping the actual policy enforcement point closer to the application. This is the use case of the sidecar proxies. And then there is Authorino as a completely satellite service of each protected application, possibly even as yet another sidecar of the application. Not that it has to be a sidecar, but anyway, as a dedicated instance of Authorino for each protected application. And what about what Authorino is not? So Authorino is not a proxy nor a gateway. Envoy is a proxy. Istio has a gateway. Authorino is not an identity provider either. It knows nothing about users. It stores no data about user identities. It's not an OpenID Connect server. It's not an OIDC authenticator. Authorino is not an OAuth 2 client, or even less an OAuth server. Authorino is not a single sign-on, an SSO server. Authorino does not store or handle sessions. It's not an identity broker for user authentication, like to redirect to GitHub SSO or to Google accounts. Authorino is not a code library to be imported and compiled as part of an application build. It's not an authorization data storage. In fact, think of it as a completely stateless application. And Authorino is not a rate limiting service as well. So hopefully at this point, you're already picturing in your mind the different kinds of things that you can do with it. To make it less abstract though, I will give an example of a relatively complex use case. It's just one use case, okay? So say you have an API running in a Kubernetes cluster. It's the My API. For a client application also running in the cluster that wants to consume the My API, there must be a service. So the client can send requests to the service hostname inside the cluster, and the request will hit the API. So the first thing we need to do here is to put this API behind Envoy, something that can be easily achieved by using some service mesh solutions, for example. Provided that we have an instance of Authorino running in this cluster, we can define an Authorino AuthConfig, which shall look like this in structure. Here we have the list of hosts the AuthConfig is protecting. And in this case, we want for the client application to be able to authenticate using Kubernetes service account token. So we are adding this type of identity verification here to the AuthConfig. So using its service account token, the application can again send requests. Envoy will communicate with Authorino, which, following this AuthConfig, will issue a token review request to the cluster underneath. Let's say if you want to be more restrictive than that and make sure that only service accounts bound to a specific role can consume the API endpoints. We can use the Kubernetes RBAC system for that. And so we add this Kubernetes RBAC authorization to the AuthConfig. Now a role binding must exist, and Authorino will also issue a subject access review that checks the permissions with the Kubernetes RBAC. Say now that we want to extend access to our API to external users that will consume the API via a CLI tool from outside the cluster. So we need to define an ingress. So now there is another host, myapi.io, that we also need to add to the AuthConfig. And say we want those CLI users to authenticate using API key secrets. Right, so we add this to the AuthConfig. And we create the API secret labeled in association with the API. API keys are shared secrets, so provided that the user knows the secret, the user can send requests to the API, and Authorino will verify the API key. Since now we have different types of users consuming the API from inside and outside the cluster, we may want to limit the API per user, so nobody can abuse the API. So we can add to the AuthConfig some Envoy dynamic metadata configuration here. So Envoy can pipe that dynamic metadata in the form of descriptors to be used by a rate limiting service such as limitador. This can be, for example, the username or the user ID to scope the limit counters within the rate limiting service. Finally, let's add the enterprise SSO server to this architecture. Being this SSO server an OpenID Connect authentication server, we can just point Authorino to the issuer endpoint of the server, and Authorino will fetch the keys to validate JSON Web Tokens, JOTs, issued and signed by the server. So, users and clients that can authenticate to the SSO server can also send requests to the API, and Authorino will verify the JOTs. So for this entire use case that I've just shown, this is a full AuthConfig that implements it. You can see here the host names to consume the API from within the cluster and from outside the cluster, the three trusted sources of identity, so the Kubernetes service accounts, the CLI users using API key, and the SSO server. And we use here the Kubernetes IBAC to store the rows and row bindings that grant access to the API, regardless of how the authentication is handled, by the way. So meaning that not only the service accounts, but also the other groups of users. And here's the bit that injects the username for the rate limiting service. Here we have a summary of features of Authorino, which I will not cover in details, of course, but just to give an idea of how many different things you can do, like multiple methods to verify identity tokens, protocols to fetch external authorization to sort the evaluation of your auth policies, different ways to implement authorization from simple pattern matching rules to OPA policies, because Authorino comes with a built-in OPA engine. Features to enable caching and conditional rules and lots of other things. And the nice thing is that you don't need to pick one of each, but you can mix and combine as many as needed. Well, and that's it for an introduction on Authorino and the reasons to externalize Auth. I hope you have enjoyed it. In our GitHub repo quadrant /Authorino, there are tons of more info than what I can cover in this session. So I totally recommend checking it out. There are docs, user guides, descriptions of the architecture, feature specification, and more. We already started building our community there. So there are a few dozens of stars already given to the repo. First questions and RFEs coming from beyond Red Hat's limits. So I invite you all to contribute and to participate. Thanks for watching.